looking at this example where z is root 2 cis pi over 3 and finding the modulus and argument, well, the easiest thing to do with this one is just to take my 2 and multiply it by z. So 2z is going to be 2 root 2 cis pi over 3. If I think about what I'm doing here, I'm just expanding the length of this complex number. So my argument isn't going to change, and it's just my modulus that's going to change. So the modulus of 2z, I can see, it's just 2 root 2. And of course my argument of 2z, I can also see, is just pi over 3. In this case, I have a product, so I'm going to use my rules. I could calculate this out and find the product, but instead I can think about the argument of I. That's just going to be, if I think about I, it points up on the imaginary axis, so its argument is pi over 2. The magnitude of I is 1, so the magnitude of iz is going to be 1 times root 2. So that's just going to be root 2. And the argument of iz is going to be pi over 2 plus pi over 3, which is 5 pi over 6. I'm going to do the same thing with this one. Magnitude of 1 minus I, well, that's root 2. And thinking about graphing 1 minus I, if I were to graph that, I would do 1 negative I, it's down here, and my angle is pi over 4. So my argument of 1 minus I is negative pi over 4. So now if I want to find the magnitude of 1 minus I times z, oops, magnitude, I'm going to get root 2 times root 2, which is 2. And my argument of 1 minus I times z is going to be negative pi over 4 plus pi over 3. And then I will get negative 3 plus 4 is going to give me pi over 12.